In this video I go through rather rapidly the November 09 non-calculator AQA Module 5 paper, bringing out along the way key points. Right, so here goes. Volume, very simple. 5 times 3 is 15, times by 2 is 30. However, if we were asked to convert it from centimetre cubed to millimetre cubed, probably easiest to think, right, well this is 50 millimetres, this is 30 millimetres, and this is 20 millimetres. Now 5 times 3 times 2 is still 30, but there's now 1, 2, 3 extra zeros, so 1, 2, 3 extra zeros, so therefore 30,000 millimetre cubed. But question 2 was a funny question. We're told that however you look at a shape, it's always circles. So from the front, from the side, a circle. From above, it's still a circle. Now, a 3D shape which looks like a circle from every angle is a sphere. In other words, a globe. So think geography of your globes of the world. And then a shape casts a shadow which is rectangular. So therefore it's got some rectangular aspect to it. Now, a cuboid clearly has a rectangular aspect to it, as could a cube. Now a cone comes to a point, as does a tetrahedron. So clearly they could not have a rectangular shadow. But a prism, which is any 3D shape with a regular cross-section, could cast a rectangular shadow. So therefore these three are all possible answers to the question. Now, this question brings out some key formulae. Now, first of all, makes you the subject. We all know that the circumference is 2 times pi times r, or 2 pi r. That's a well-known formula. However, suppose pi is 3.14 and r equals 3, and we want to find the circumference. So we have to work out what 2 times pi times 3 is. Well, 2 times 3 is 6, so what's 6 times pi? Using pi to be 3.14. Well, you can do this in your head, but if you're not sure and want to just get it exactly right, then one option is to use the grid method to check your answer. In the grid method, we draw a grid. We put 3.14 across the top and 6 down here, and put down here diagonal lines. And 3 times 6 is 18, 1 times 6 is 6, 4 times 6 is 24. Then add up the diagonals, 4, 8, 8, 1. Decimal point as whizzes down, goes to here. So the answer is 18.84 centimetres. Doesn't take that long, and it's worth 2 marks, so it's worth doing it properly. Now then, part C then uses this question. So we've now got a quarter circle. That's 90 degrees in here. And we've got some equilateral triangles. So all these lengths are going to be 3. And the question is find the perimeter of the shape, which is basically that, 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 and that. Now 3, 6, 9, 12, we've definitely got 12 here for the triangle parts. But this bit here we haven't found yet. But this is a quarter of a circle. Now we know from before that if it was a full circle, it'd be 18.84. So this curved part is 18.84 divided by 4. Well, how many 4s are there in 18.84? .71. So the total perimeter is 16.71 centimetres. So to summarise, the full circle was 18.84. This was a quarter circle, so we divide the answer by 4, then add on the 4 threes to get 16.71 1. Now in 3-part C, we've got to work out an angle x. Now on the face of it, this appears a difficult question, but it's not when we begin to fill things in. Now from before, these were quarter circles, so 90. These are just the angles, and these were equilateral triangles, so that must be 60, must be 60, must be 60, must be 60. Now, because these angles here form a point, 90 and 120 are 210, well 360 is a full circle, take 210 is 150, so this must be 150, and so this must be 150, and the whole shape is symmetrical, so this must be x. Now 150 and 150 is 300 degrees, 4 sides must be 360 in total. Now 360 take 300 is 60 degrees, so x and x must make 60, so x must be 30 degrees. So the trick to answering this sort of question is just to fill in as much as you can and then deduce the final answer at the end. Now question 4 begins as just a coordinate question. So we're given 4 coordinates and we're going to plot them. So 2 across 1 up, 2 across 1 up, 8 across 9 up, 12 across 9 up, and 6 across 1 up forms a parallelogram, which I will just sketch so we can see it. And the question says is, what is the area of this parallelogram? Well, the base goes from 2 to 4, so it's got a base of 4, and the height of the parallelogram is from 1 to 9, so it's 8. The area is 4 times 8, which is 32 centimetres squared. Now, the next part of the exam then says find the perimeter of the parallelogram. Now we know this is 4, and that's 4, so 4 and 4 is 8, but what we're missing are these two lengths, like so. And the trick here is to use Pythagoras. Now just consider that length there. This is 8, and this length here is 1, 2, 3, 4, 5, 6. And so Pythagoras says that given a right angled triangle, A, B and C, that A squared plus B squared equals C squared. So if we call this length here C, 6 squared plus 8 squared must equal C squared. That's 36, that's 64, equals C squared, so C squared equals 100, therefore C must equal 10. So therefore that equals 10, that equals 10, 10 plus 10 is 20, 4 plus 4 is 8, total perimeter is 28 centimetres. Not an easy question, but one that is certainly worth being aware about how to solve. Here we go. We've already done this question. That was 28 centimetres. These are now more standard questions. Work at the value when C is 0.4 and H is 2.5. Well, 5 lots of 0.4 minus 4 lots of 2.5. 5 times 4 is 20, so 5 times 0.4 is 2. 4 times 2.5 is 10. 2 take away 10 is minus 8. And then, an equation to solve. When you've got brackets, the trick is to expand the equation brackets first of all. So 4 times x is 4x, 4 times 7 is 28. We now take 4x from both sides. Take 11 from both sides. Be very careful. Take away 11, we get to minus 39. So x equals minus 39 over 3, which is minus 13. Make sure you've revised very carefully equation solving before this Module 5 examination. Now question 6 is then a very, very easy question. It begins by saying describe an equation of this form. Well, these equations of the form y equals something x plus something else are always straight sloping lines. Always are. And we can find coordinates on these lines very simply by doing a table of values. Often 0, 1, 2 are good ones to choose. So when x is 0, 2 times 0 is 0, take away 1 is minus 1. When x is 1, 2 times 1 is 2, take away 1 is 1. And when x is 2, 2 times 2 is 4, take away 1 is 3. So this gives us lots of coordinates. We've worked out 3 coordinates, it asks for 2. The first one could be 0, minus 1. The next could be 1, 1, and so on and so forth. But that's how you find the coordinates of lines. Now, part C then says in reverse, suppose y is 2.8. So 2.8 equals 2x minus 1. What value of x gives that as an answer? Well, if we add 1 to both sides, we get 3.8 equals 2 lots of x. So x must equals 3.8 divided by 2, which is 1.9. And then solve the inequality. It's the same question. We add 1 to both sides, so 2x is less than 3.8. Divide by 2, x is less than 1.9. But leave the answer as an inequality. Here we go. This is now a nice question. Milan to Venice is 300 kilometres. If we get a ruler out and measure this, we find that the actual distance is 25 millimetres, which is 300 kilometres. And the question is how far is it from Venice to Naples? Well, Venice to Naples works out to be approximately 58 millimetres. Show you again. Venice to Naples is just below 6, about 58 millimetres. So what's that kilometres? Well, the trick here is to think, right, what is 1 millimetre going to be worth? Well, how many 25s are there in 300? Well, there are 4 in 100, so therefore 12 in 300. And so therefore 58 millimetres will equal 58 lots of 12. Excuse me. 58 lots of 12, which can be done very quickly. 580 plus 58 plus 58, which is 680 plus 16, which is 696 kilometres. And there we go. So when you've got scales, try to work out what one of those units equals. Then from that you can convert up to find a larger distance. We then move on to a bit of algebra, a bit of standard algebra. Factorise. 20x take away 12. Well, a common factor of 20 and 12, the highest common factor is 4. It's 4 lots of 5x to get 20x, take away 3. That's been factorised. This is an example of a linear factorisation. This here is your quadratic factorising. With 2 brackets, we need a factor pair of 12, which add to make 7. Well, 4 and 3. 4 times 3 is 12, 4 plus 3 is 7, that's therefore been factorised. Now this one marker here is a little trick question. These are called factors, and if we let x equal either -4 or -3, this answer here will always equal 0. It's worth knowing that. Now then, 8 part C, equations involving fractions. Now, I'm going to do this one a bit further down, so we've got a bit more space. The trick here is to, first of all, imagine them all over fractions, including the 7. And then look for a common factor of 2, 3, sorry, a multiple of 2, 3 and 1. What does 2, 3 and 1 go into? Well, the answer is 6. So we put all of these over 6. Now how many 2's in 6? 3. So times the top by 3, we get 3x plus 9. How many 3's in 6? 2. So times the top by 2, 4x minus 2. And how many 1's in 6? 6 times the top by 6, we get 42. And then cancel off the bottoms. Then simplify. 3x plus 4x is 7x. 9 take away 2 is 7 equals 42. Take 7 from both sides. 7x equals 35. Then how many x's are there in? So how many 7's in 35? 5. So x equals 5. Now question 9 is about similar shapes. Now we have 2 corresponding shapes here. And the question is what do we have to times or divide by to get from 8 to 12? That shows our ratio. Well, 12 is 1½ lots of 8. A half of 8 is 4, so it's 1½ lots of 8. But conversely, 8 is 2/3 of 12. A third of 12 is 4, so 8 is 2/3 of 12. So to find what z is, we have to work out what 2/3 of 15 is. Well, a third of 15 is 5, so 2/3 of 15 is 10. So z equals 10 centimetres. We then get to some very, very, very easy marks. Further on in the exam, there can be some marks which are far easier than anything else you've met so far, as long as you know the facts. Now then, fact 1. If we know an angle at the circumference, the angle at the centre is always twice it, so that must be 80. Because they form a circle, x must equal 360, take 80, which is 260, so 280 degrees. And then for the second one, find y. It's a really important fact, and it's called the alternate segment theorem, which is that this angle here, y, will equal this angle here, y equals 50. In fact, this angle would equal 70. So that angle equals that one, and that one equals that one. It's called the alternate segment theorem. And it makes a top grade question really rather easy to answer. Now, I'm just going to dip in and out of a few of the final questions to show you the key ones. Now, forget about the right hand side. We're told we've got a cone which has got an area of 15 centimetres squared and a height of 16 centimetres. Now, in the front of the examination, you're told that the volume of a cone is 1/3 base times height. Now for this large cone, the base is 15, the height is 16. Well, 1/3 of 15 is just 5, so it's 5 times 16, which is 80 centimetre cubed. And that is therefore the volume of the large cone. And in question 14, show this equals that. Well, the simplest way, when you've got brackets, I think, is the grid method. 4x and y, 3x minus 2y, 12x squared, 3xy, minus 8xy, minus 2y squared. Well, 12x squared, 3 take away 8 is minus 5xy, minus 2y squared. That shows the answer rather convincingly for 1 mark. And then hence simplify. Well, we've shown how the top can be written as 4x plus y, 3x minus 2y. That's the top part. Well, the bottom part is already there for us. Well, that goes with that, that goes with that. It cancels out, we're left with 1 as an answer. And finally, x and y represent integers, x is even. Show or explain why this is also even. Well, if x is even, then y is either even or odd. That's case 1, that's case 2. Let's write this out below again. Case 1. If x is even, then 4x is also even. And if y is even plus even is even. So whatever that equals, though x and y are both even, that must also be even. Even times even is always even. Case 2. X is even, y is odd. Well, 4 times x is even, y is odd, so even plus odd is odd. However, x is even, so 3 times even is even, y is even, so y is odd, so 2 times odd is also even. Even, take away even, is even. And odd times even is always even. And that shows why the answer always will be even, whatever x and y happen to be.